When sending data to an API, on creation for example, we have to send over a content type header. We just did that in the demo. So there's now 3 places to set some or all request headers. One on HTTP client.default request headers. This is good for default values that remain the same across requests. 2 via HTTP request message.headers. These are headers like accept encoding, authorization and so on, i.e. headers that can be set for requests with an empty body and with a request body. They don't have anything to do with the content of the message. 3 on HTTP request message.content.headers. And these headers relate to the content of the message, like content type. Note that you cannot set the content type header on HTTP client directly, as it relates only to the content of the message. Next to this, we can also set the content type indirectly by passing it through via an HTTP content type deriving object, like string content. That's the same as setting it on content.headers.content-type. Let's have a look at that HTTP request message.content object in some more detail. It's of type HTTP content. That's an abstract base class. We cannot use that directly. Depending on the type of content of our message, we can set the content object to one of the classes that derive from HTTP content. Often used are string content, object content, byte array content, but we'll also use others during the course, like stream content. Save for the easy-to-use extension methods for specific scenarios, it's best practice to use these classes when you can, because they're optimized for working with the type of content they relate to. Let's continue with updating a resource. In this demo, we'll learn how to update a resource by using the put_HTTP method and an HTTP request message object. Let's first add a new action, update resource. Let's say we want to change the description of the Pulp Fiction movie in our database. Put is for full updates only, so we have to pass through all the fields and not just the description. We'll look into an alternative, patch, which allows partial updates in the next module. So we create our object, a movie for update, again coming from the generated model classes. We input values for all the fields, but we change the description to something else. And let's serialize it to JSON. We still know how to do that from the previous demo. And now we create our request message. This time the method is put. The URI is the resource URI of the Pulp Fiction movie. We set the accept header to application JSON, and we set the content property to a new string content object, passing through the serialized movie to update. Here too the content type is application JSON, so we set the content type property as well. And the rest is pretty much like what we're already used to. We call send_async, passing through the request, and we ensure we get a successful status code back. After that, we read out the content as a string, and we deserialize the JSON from the response body into a new movie object. Let's put a breakpoint here, and let's make sure we call this method. Let's give that a try. We hit our breakpoint. Let's have a look at the response. We got back status code 200, so everything seems okay. And we indeed get an updated movie object, including our new description. Up next is deleting a resource. In this demo, we'll learn how to delete a resource. Let's add a method for that, delete resource. This one will be quite a bit shorter than getting, updating, or creating a resource. To delete a resource, we should send a delete request without content to the URI of the resource we want to delete. So we create a new request with method delete and the URI to our Pulp Fiction movie. If all goes well, a successful delete request returns a 204 response with an empty body. Yet we still want to add an accept header. Some APIs return content in case something goes wrong, and that too has to be serialized. Then we send request, we ensure everything worked out fine, and we read out the content. If everything goes well, that should be empty. So let's put a breakpoint here. Let's call this from the run action. And let's give this a try. We hit our breakpoint. Let's have a look at the response. We got back at 204. So far, so good. And our content is indeed an empty string. That's it for deleting a resource. As is clear by now, there's a lot of ways to specify how a request should be formed. And what you want to use often comes down to personal preference as much as a requirement. I lined up some alternatives, which are all just shortcuts for what we've done. Let me paste those in and we'll run through them. We already know how to use getAsync, so let's look into postAsync. This is the shortcut alternative for sending a post request. We pass through the resource URI and a new string content instance. We instantiate that with the content, i.e. the serialized movie to create. We pass through the encoding we want to use and the media type. This one will be used for the content type header. Let's compare this to what we previously had. As you can see, this code is a lot more concise. For sending a put request, a likewise alternative exists, putAsync, following the same principles as postAsync. And then there's deleteAsync, which is even shorter. We only have to input the URI of the resource we want to delete. So why not just use these shortcuts all the time? Well, there's an important gotcha here. When using these shortcuts, the accept header isn't automatically set nor sent. And we know that for RESTful systems, that's obligatory. As we know, we can set a default accept header at client level, but that's only okay when all your requests have to be sent with the same accept header. So, to set the accept header or other headers on a per request basis, the way to go is to not use the shortcuts, but use the original approach with HTTP request message we detailed before. So, depending on your requirements, the shortcuts may not be feasible. Personally, I tend to use HTTP request message instead of the shortcuts. And with that, let's have a look at the summary. In this module, we learned about basic interaction with an API. But arguably more important than the code are the best practices we learned. Request headers contain more information on the resource to be fetched or about the client itself. It's the responsibility of the client, be it a browser or our HTTP client instance, to provide these. So we should do that. Always provide an accept header to avoid unforeseen errors. The headers of a response then contain information on the generated response or server. These are thus generated by the API or an in-between mechanism. It's a good idea to check the content type header of a response to know which deserializer to use when both API and client support multiple formats. We learned that we could set these headers in various places, but it's important to set them in the right place. Default values that remain the same across requests can be set via HTTP client.default request headers. Headers that apply to the request regardless of it having a request body, in other words, that don't apply to the request body, can be set via HTTP request message.headers. And lastly, headers related to the request body, the content of the request, can be set via HTTP request message.content.headers. We also learned there's quite a few shortcut methods we can use. While these can come in handy and are certainly okay to use, they do come with a few limitations. Most of them either make assumptions on what you want to see returned or don't allow in-depth configuration. If you need that, use HTTP request message directly. And with that, we covered basic create, read, update and delete operations. Save for one, and it's an important one, the partial update. Let's check that out in the next module. These days, APIs often allow partial updates through patch, as that is what patch is intended for, next to improving performance. We'll learn how to consume such an endpoint in this module. We'll start by looking into the patch method and the standard to describe the request body of such a patch request, the JSON patch standard. We'll also implement it and we'll look into advanced scenarios. Let's dive in. According to the HTTP standard, a PUT request should replace the current resource with a new one. That implies that all fields must be overwritten with whatever is sent in the request body. PUT is thus only intended for full updates. However, you don't necessarily want to do that. It creates a lot of overhead because for you to change one field, you'll have to send over all fields, which often also means having to get the full resource first. Therefore, the best practice today is to use patch for updates instead of PUT, as patch allows partial updates. But that does mean we need a way to pass a change set to a resource using the HTTP patch method. In other words, we need to be able to describe such a change set. And there's a standard for that, the JSON patch standard. That one defines a JSON document structure for expressing a sequence of operations to apply to a JSON document. You can look at that structure as a change set, a set of operations that will be applied the patch request is targeting. This is fully supported by ASP.NET Core, both at API level and at client level. Note that in principle, the application JSON patch plus JSON media type is used to identify such a document. But most APIs tend to allow application JSON as well as a content type for those types of documents. But we're going to implement it as it was intended. Let's have a look at such a request body. Imagine that this is a patch request to a specific movie. It starts with straight brackets, signifying an array. And that array, that's a list of operations that have to be applied to the movie. We see two operations in the example on screen. The first one is a replace operation, signified by OP. Path signifies the path to the property, title in this case. And value signifies the new value that should be given to the title property, new title. The second operation removes the description of a movie. The operation is set to remove, and path is thus description. There's no value as the property will be removed. Removing for most systems means setting the field to its default value. For some dynamic systems, it can mean actually removing the property from the resource. Let's have a look at the other operations. The add operation will add a property at a path location with a specific value, passed through via value. If it's used on a path that exists, that property's value will be replaced. We already covered remove and replace. Copy will take the value of the from property and copy it over to the path property. It's thus an add operation at the path location with the value specified in the from member. Move will copy over the value at the from property to the path property and remove the value at the from property. So functionally, this operation is identical to a remove operation on the from location, followed by an add operation at the path location with the removed value. And lastly, test tests that a value at the target location is equal to a specified value. So we have to create a request message with such a list of operations as the request body. And we can do that manually, but there's helper classes available for this. Let's have a look at that with a demo.